Hi everyone, welcome to my channel. So this is the first video that I'll be posting to my channel, and here I'll be solving this maths past year paper where the syllabus code is 9709, and I'll be solving this year paper, which is May-June 2018, paper number 13. So let's move on to the first question from this question paper, and that is this one. So they have said in this question that we have to express this quadratic equation in this form. So here what we can do first is we can take 3 common from these first two terms, and if we do that, so 3 in brackets, then we're going to have x square minus 4x plus 7. So this is the first step. So next, see, we have this expression in the brackets. So we have to now express this expression in this format, which is x plus b whole square. And there is a formula that you can use to do so. So whenever you have some expression in this form, x squared plus bx. So if you have an x squared term where the coefficient of x squared is 1, and another term of x where the coefficient is b, where b can be any value. Okay, so there's a formula for that, and that is x plus b by 2 whole square minus b square by 4. Okay, so this is the formula that we are going to apply out here. So if we compare this expression with this form, so we have x square minus 4x. So see, this can be written as x squared plus of minus 4x. So here if we compare this, our value of b comes to minus 4. One thing I'd like to point out is this b is not same as the b given in this form. So be careful about that. So let's apply the formula now. So it will be x plus minus b by 2 bracket to the power of 2 minus minus b, which is minus 4 whole square by 4. So now if we have minus 4 by 2, so that is going to give us minus 2, and x plus of minus 2 will be minus 2x minus 2. So x plus of minus 2 whole square minus, so minus 4 whole square will give us 16. So 16 by 4. So the last part will be x minus 2 whole square minus 4. So once we get this expression, we are going to substitute it back out here. So 3 bracket x minus 2 whole square minus 4 bracket close plus 7. So next step will be to open up the brackets. So it will be 3 bracket x minus 2 whole square minus 12 plus 7. So this can be written as 3 x minus 2 whole square and minus 12 plus 7 gives us minus 5. So if we compare our answer with the form given in the question, so a comes to 3, b has a value of minus 2, and c is equal to minus 5. So this is the final answer for question number 1. So let's move on to the next one. So here we have to find the coefficient of 1 over x in the expansion of x minus 2 by x whole to the power 5. So whenever we have something like this, a plus b to the power of n, we can apply this formula, that is NCR, a to the power of r and b to the power of n minus r. So see this expression, which is x minus 2 by x to the power of 5, can be written as x plus of minus 2 by x whole to the power of 5. So if we compare this with this form, so a is equal to x, b is equal to minus 2 over x, and n is equal to 5. So if we apply the NCR formula now, so this is going to be 5CR x to the power of r and minus 2 by x whole to the power of 5 minus r. So we can break this even more. So this will be 5CR x to the power r into minus 2 to the power 5 minus r into x to the power minus 1 to the power 5 minus r. Why? Because this x is in the denominator. So when we bring it to the top, so we have to put this minus 1 out here. So see, this is a constant and this will also give you another constant. So the next step will be to identify the x term. So this is the first x term, x to the power r, and this is the next one, x to the power minus 1 into 5 minus r. So we have to use these two terms to find the value of r. So step number 2 is to find the value of r. So first term is this, which is x to the power r, into this one, which is x to the power minus 1 into this, will give us minus 5 plus r, and that is equal to the x term whose coefficient we have to find out. So here they have given, we have to find out the coefficient of 1 over x. So this can be written as x to the power minus 1. So now we can write x to the power minus 1 out here. So next step will be to equate all the powers. So this will be r, and since we have a multiplication sign out here, so we can add the powers. So it will be r plus of minus 5 plus r equals 1. So it will be r minus 5 plus r equals 1. So r plus r will give us 2r, and if we take this minus 5 and take it to the other side, so 1 plus 5, and that will give, sorry, my bad, this was minus 1. So minus 1 plus 5, so that will give us 4. So r will be equal to 4 over 2, which will give us 2. So once we get the value of r, then we have to use that value of r in this expression to get the final coefficient of the term that we are looking for. So next, using the value of r, so this will be 5c2. In place of r, we are going to put the value of r that we got, which is 2, into x to the power of 2 into minus 2 to the power of 5 minus 2 into 1 by x to the power of 5 minus 2. So 5c2, if we want to find that out, that will come to 5c2, that comes to 10. So this will be 10 into x square and minus 2 whole to the power 3. So minus 2 cube will give us minus 8 into 1 by x cube. So this x squared term and this gets cancelled, leaving me an x term in the denominator. So this will be minus 81 by x. So finally the coefficient of 1 over x is equal to minus 80. And that is our final answer for question number 2. Now let's move on to the third question. So in question number 3, they have said that the common ratio of a geometric progression is 0.99. Express the sum of the first 100 terms as a percentage of the sum to infinity, giving your answer correct to two significant figures. So let's jot down the data that has been given to us. So it's a geometric progression where the common ratio, which is denoted by r, is equal to 0.99. And the sum of the first 100 terms, that means n will be equal to 100. So in GP, the formula for sum of the first 100 terms, or the sum of the first n terms rather, will be a into 1 minus r to the power n by 1 minus r, where a is equal to the first term of the progression. So here, since we have to use sum of the first 100 terms, so n will be equal to 100 and the formula will be a into 1 minus the value of r that has been given to us, which is 0.99 to the power of 100 divided by 1 minus 0.99. So 1 minus 0.99 is 0.01. So this will be a into 1 minus 0.99 to the power of 100 by 0.01. So next we have to use the formula for sum to infinity. So sum to infinity, the formula for that is a over 1 minus r. So this will be equal to a over 1 minus 0.99, which is a divided by 0.01. So that we have to give the answer for the sum of the first 100 terms as a percentage of the sum to infinity. So it is the expression of sum of the first 100 terms by the sum to infinity into 100. So that is equal to a into 1 minus 0.99 to the power of 100 by 0.01 divided by the expression for the sum to infinity that we got, which is a by 0.01 into 100. So since we have a division sign out here, so if we change it to multiplication, so we can flip this expression. So this is a into 1 minus 0.99 to the power of 100 by 0.01 into 0.01 by a into 100. So from here we can cancel out this 0.01 and this 0.01. We can cancel out this a and this a. So now we have to calculate 1 minus 0.99 to the power 100 into 100. So let's bring out our calculator for that. So 0.99 to the power of 100 comes to this. So 1 minus this gives us 63396. So into 100 it comes to 63.396 and so on. But see, we have been asked to give our answer correct to 2SF, two significant figures. So if we round off this answer to 2SF, so it will come to 63%. So our final answer will be 63% correct to the nearest two significant figures. And this is our final answer for question number 3. So let's move on to the fourth question. So here they have said that we have a curve with equation y equal to fx, which is passing through the point A 3, 1 and it crosses the y-axis at P. It is given that f prime x is equal to 3x minus 1 whole to the power minus 1 by 3 and we have to find out the y coordinate of P. So again, first step is to jot down whatever information they have given us. So the equation is y equal to f of x and the first derivative f prime x is equal to 3x minus 1 to the power of minus 1 by 3. So from here, if we want to find out the equation of the curve from the derivative, what do? We integrate the expression of dy by dx. So we can write that y is equal to integral f prime x dx. So integral 3x minus 1 to the power of 1 by 3 minus 1 by 3 dx. So if we integrate this, so if you have suppose integral ax plus b to the power of n dx, what is the formula for doing that? So it will become ax plus b. You increase the power by 1, so n plus 1 and then you divide this expression by the new power which is n plus 1 and the coefficient of x which is a. And since there are no limits out here, so you have to add this plus c at the end. So let's use the same concept out here. So this will become 3x minus 1 to the power minus 1 by 3 plus 1 divided by minus 1 by 3 plus 1 into 3 plus c. So let's simplify this further. So this will be 3x minus 1. So minus 1/3 plus 1 gives us 2 by 3. That divided by 3 into, this will give us again 2 by 3. So this 3 and this 3 gets cancelled, and our final expression will be half into 3x minus 1 2 by 3 plus c. Okay, so this is the equation, the general equation of the curve. So they have said that this is a point on the curve. So by using the coordinates of this point, we should be able to get the constant c. So let's do that now. So at A, where the coordinates are 3, 1, so this is the x coordinate and this is the y coordinate. So we can write that 1 is equal to half bracket 3 into the x coordinate, which is also 3, minus 1 bracket close 2 by 3 to the power 2 by 3 plus c. So this can be written as 1 equals half. So 3 times 3 is 9. So 9 minus 1 is 8. So 8 to the power of 2 by 3 plus c. Okay, so now let's bring out our calculator. So here we have 8 to the power of 2 by 3. 1 second. Okay, so that comes to 4. So this will be 1 equals 4 plus c. So c should be equal to 1 minus 4, and that comes to minus 3. One more thing, there is a half out here, so I skipped that. So this will be 1 equals half into 4 plus c. So that is 1 equals 2 plus c, and from here we can say that c is equal to minus 1. So by using this c value, we can get our final equation of the curve, which is half bracket 3x minus 1 to the power of 2 by 3 minus 1. Okay, so this thing that I've got, this expression that I've got, it is the equation of the curve. So next what they're saying is, the curve crosses the y-axis at B. So what is the equation for y-axis? It is x equals 0. So to get the y-coordinate of B, what we can do is we can just substitute the value of x. So at the y-axis, so I'll write that down out here. So at the y-axis, x is always equal to 0. So this will be y equal to half bracket 3 into 0, because here we have to replace this x with the value of x, minus 1 to the power of 2 by 3 minus 1. So that is equal to half. So 3 into 0 is 0. 0 minus 1 is minus 1. So minus 1 to the power of 2 by 3 minus 1. Okay, so that will give us half minus 1. And our final answer will be minus half. So the y coordinate of B is equal to minus half. Y coordinate of B is equal to minus half, and that is our final answer for question number 4. Hopefully you guys are able to follow me so far. So next we'll move on to the 5th question from this paper. and that is a question of circular measure. So here we have been given this right angle triangle, and they have said that OA is equal to 5 centimeter. The arc AC is part of a circle with center O. The arc has length 6 centimeter and it meets OB at C. So we have to find out the area of the shaded region, okay, which is this gray part. So how can we do that? So over here, see, we have this sector, rather AOC is a sector, and if O is the center, that means this is the radius of that sector. So radius of the sector is 5 centimeter. So AC is the arc, right? So OA is the radius. That means OC will also be equal to the radius. So even this should be equal to 5 centimeter. So we have been given the radius and we have been given the arc length. So we can easily find out this angle by using the formula for arc length of a sector. Okay, and what is the formula for arc length of a sector? So the formula is S is equal to R theta, and this theta must be in radians. Okay, so theta will be equal to S over R. Okay, S is the arc length and R is the radius. So in this question they have already mentioned that arc length is 6 centimeter. So 6 over 5, so that should come to 1.2 radians. So this angle is now coming to 1.2 radian. So see, we have already been informed that this is a right angle triangle and this angle is coming to 1.2 radians and this is 5 centimeter. So we should be able to find out this side of the right angle triangle. We can find out side AB. So if I redraw that right angle triangle out here, okay, so this is equal to 1.2 radian. This side, this is O, this is A, and this is B. So this is 1.2 radians. So AO is 5 centimeter, and we want to find out side AB, and this is 90 degrees. So this is the base, and this side is the perpendicular. So we can use tan. So tan of 1.2 is equal to perpendicular by base. Perpendicular is AB and base, which is AO, is 5. So AB will be equal to 5 into tan of 1.2. Okay, so now we have this side and we can find out the area of this right angle triangle. So by subtracting the area of this sector, the white portion, from the total area of the right angle triangle, so that will give me the area of this shaded portion. So area of a right angle triangle, so area of triangle OAB will be equal to half into base into height. So half into base is 5. So 5 into AB, which is the height, is 5 into tan of 1.2 radians. Okay, so next, once we get this area, we can subtract the area of this sector from this value. And what is the formula for area of a sector? It is half r square theta. But before that, let's find out how much is this coming to. So again, let's use our calculator for that. So before we calculate this, please ensure that your calculator is in radians mode because the angle is in radian. So switch your calculator to radians mode if it is already not in radian mode. And once you're done with that, so the value should be 0.5, half into 5 times 5 is 25 into tan of 1.2, and see that comes to 32.15. So 32.15 centimeter square is area of this right angle triangle. So next step is to find out area of the sector OAC, and the formula, like I told earlier, it was half r square theta. So half into 5 times 5, which is 25, into the theta value is 1.2. So again, let's use our calculator. So 0.5 into 25 into 1.2, it comes to 15. So that is the area of the sector. That means area of the shaded region will be area of the triangle, right angle triangle, minus area of the sector. So area of the shaded region will be equal to area of the right angle triangle OAB minus area of the sector OAC. So it will be 32.15 minus 15. So 32.15 minus 15 should come to 17.15. So 17.15. So when you round your answer to the nearest three significant figures, it should be 17.2 centimeter square, and that is your final answer. In maths, please remember to always round off your answer to three significant figures unless they have specifically mentioned to do some other approximation. So now let's move on to the next question on this paper. So here they have said that the coordinates of points A and B are minus 3k minus 1 comma k plus 3. That means this is the x coordinate of A, and this is the y coordinate of A. This is the x coordinate of B, and this is the y coordinate of B. And they have said that k is a constant and k is not equal to minus 1. So we have to find and simplify the gradient AB, showing that it is independent of k. Okay, so let's do that. So if we have 2 points and we are asked to find out gradient, so what is the formula? It is y2 minus y1 divided by x2 minus x1. I hope you guys are familiar with this formula. So here when we want to find out the gradient of AB, that means it will be y coordinate of B minus y coordinate of A divided by x coordinate of B minus x coordinate of A. So now just put this expression in this formula. So it will be 3k plus 5 minus the y coordinate of A, which is k plus 3. Remember to use brackets, divided by the x coordinate of B, which is k plus 3 minus the x coordinate of A, which is minus 3k minus 1. So now let's open up the brackets. So it will be 3k plus 5 minus k minus 3 by k plus 3 plus 3k plus 1. So 3k minus k will give us 2k. 5 minus 3 will give us plus 2. K plus 3k will give us 4k, and 3 plus 1 gives us 4. So say from the numerator we can take 2 common, and that is going to give us k plus 1 in bracket. And from the denominator we can take 4 common. So if we take 4 common, again in the brackets we're going to have k plus 1. So see, this k plus 1 and this k plus 1 can get cancelled, and we are left with 2 over 4, which can be simplified further to half. So the gradient comes to half. And see, this is independent of k because you do not have k in your final answer. I hope this is clear. So this is the answer for question part 1. Now let's move on to part 2 of this question. So part 2 says find and simplify the equation of the perpendicular bisector of AB. Okay, so suppose we have one line like this. So suppose this is our line AB. So perpendicular bisector is just a perpendicular line which will pass through the midpoint of this line AB. So if I draw another line like this, okay, so this green line that I've drawn, it's a perpendicular line also known as a normal. So the angle between this green line and this red line will be 90 degrees, and this perpendicular line or this normal should always pass through the midpoint of this line AB. Okay, so since the line AB and the green line which represents the normal, they are right angles to each other, so we can first find out what will be the gradient of this normal. So whenever two lines are perpendicular to each other, the product of their gradients is always equal to -1. So a quick note, if two lines are perpendicular to each other, okay, so suppose M1 is the gradient of line 1 and M2 is gradient of the second line. So the product of these two gradients will be always equal to -1. Okay, so we can find out M1 by just doing -1 divided by M2. That is only applicable if the two lines are at right angles to each other, and if the two lines are parallel to each other, then their gradient will be same. So we can say that M1, which is gradient of line 1, should be equal to M2, which is the gradient of the second line. So in this case, since we are talking about perpendicular bisector, which is a line that is at right angles to AB, so we have to use this concept. So we can write that gradient of AB into gradient of the normal is equal to -1. So from part 1 we had already found out the answer for gradient of line AB. So we can write that half into gradient of normal is equal to -1. So gradient of the normal should be equal to -1 times 2, which is -2. So now we have got the gradient of this line. Next we need to know what is the coordinates of this point M, because what is the formula to find out equation of any straight line? It is y minus y1 equals m brackets x minus x1. What is m? M is the gradient of that line, and x1 and y1, they represent the coordinates of a point falling on that line. So coordinates of a point on that line. So if we look at our diagram, so this point M, which is actually the midpoint of line AB, is a point which falls on this perpendicular bisector. So we have already got the value for M. We just now need to know the values of x1 and y1. So now second step will be to find out the coordinates of M. So what is the formula to find out coordinates of the midpoint? The formula is x1 plus x2 by 2, comma y1 plus y2 by 2. So in this case, since we're using points A and B, we can write that xa plus xb, that means x coordinate of A plus x coordinate of B by 2 will give us the x coordinate of this midpoint, and ya plus yb will by 2 will give us the y coordinate of the midpoint. Okay, am I clear till now? So now let's put in the values of xa and xb. So xa is minus 3k minus 1. So minus 3k minus 1. Let's see what's xb. xb is k plus 3. So plus k plus 3, that divided by 2. Next ya, which is k plus 3 plus yb, which is 3k plus 5. So that divided by 2. So now let's simplify this. So if we group the like terms together, so minus 3k plus k, that will give us minus 2k, and minus 1 plus 3, that should give us plus 2. So that divided by 2. And here k plus 3k, that will give us 4k, and 3 plus 5 will give us 8. So that divided by 2. So now we can simplify this even more. So if we take 2 common from the numerator, so it will give me minus k plus 1, that by 2. And if I take 2 common from here, so it will give me 2k plus 4 by 2. So see, this 2 and this 2 gets cancelled. This 2 and this 2 gets cancelled. So we are left with minus k plus 1, which is the x coordinate of the midpoint, and 2k plus 4, which is the y coordinate of the midpoint. So we have got all the information that we need to use in this formula. So now let's just put in the expressions in this formula. Okay, so to find the equation of the normal, so it will be y minus the y coordinate of the midpoint, which is 2k plus 4. That is equal to the gradient of the normal, which we found out was minus 2, bracket x minus x1, which represents the x coordinate of the midpoint, which is minus k plus 1. So if I put this in bracket, it will help me, because when I open up the bracket, since there's a minus sign out here, so this plus will change to minus. So it will become y minus 2k minus 4, that is equal to minus 2 bracket x, minus into minus is plus, so plus k, and minus into plus gives minus, so minus 1. So y minus 2k minus 4 equals minus 2x minus 2k, and minus into minus again gives plus 2 plus 2. So this minus 2k and this minus 2k should get cancelled. Why? Because if I take this minus 2k to the right hand side, so minus 2k plus 2k should be 0, right? So next will be y minus 4 equals minus 2x plus 2. So this will be minus 2x. So if I take this minus 4 to the right hand side, so minus 2 minus 4, plus 2 plus 4 should give me 6. So your final answer will be y equals minus 2x plus 6. This is the equation of the perpendicular bisector that you have to find out. So this is the entire working for question part 2. I hope this was clear. Now moving on to the 7th question from this paper. So we have to express this in the form of a sine squared theta plus b. So now let's start doing this. So for this you can use the identity that tan theta is same as writing sine theta by cos theta. So since we have tan squared theta, so if we square the left hand side of the equation, then we have to square the right hand side as well. So tan squared theta is basically sine theta by cos theta whole square. So this can be written as sine squared theta by cos squared theta. So next, instead of writing tan squared theta, I'm going to write this. So sine squared theta by cos squared theta minus 1. This is the numerator, tan squared theta minus 1. So I'm going to do the same thing for this tan squared theta. So divided by sine squared theta by cos squared theta plus 1. Okay, so now I can rewrite this as sine squared theta minus cos squared theta by cos square theta, and repeat the same thing in this case. So it will be sine square theta plus cos square theta by cos square theta. So if I change this to multiplication sign, that means I can flip this side of the expression. So this will become sine square theta minus cos square theta by cos square theta into cos square theta by sine square theta plus cos square theta. So this cos square theta and this cos square theta gets cancelled. So the next identity that we can use is sine square theta plus cos square theta is always equal to 1. That means this part of the expression will now change to 1. So we are left with sine square theta minus cos square theta. Okay, so now if I make cos square theta the subject and bring sine square theta to the right hand side, so it will become 1 minus sine square theta. So I can substitute that out here. So it will be sine square theta minus, now instead of writing cos square theta, I'm going to use this expression. So it will become bracket 1 minus sine square theta. So let's open up the brackets now. So it will be sine square theta minus 1 plus sine square theta. So see, we have sine square theta plus sine square theta. So that will become 2 sine square theta minus 1. So if we compare this answer with the form given, so we can conclude that A will come to 2 and B is equal to minus 1. Okay, so this is your final answer for 7A part 1. Now let's move on to part 2 of this question. So they have said hence or otherwise, and showing all the necessary workings solves the equation tan square theta minus 1 by tan square theta plus 1 equals 1 by 4 for this range of theta. So now instead of writing this, we can use this relationship, which is 2 sine square theta minus 1. So 2 sine square theta minus 1 is equal to 1 over 4. So that is for this range from minus 90 all the way to 0. So now what we can do is we can take this 4 and multiply it to the left hand side. So 4 into 2 sine square theta minus 1 is equal to 1. So 8 sine square theta minus 4 is equal to 1. So now let's take this 4 and bring it to the right hand side. So 8 sine square theta will now be equal to 5. So sine square theta will be equal to 5 over 8. So now I have to take square root. So whenever you take square root, please remember to plug in a plus minus sign. So now we can write that sine theta is plus minus square root of 5 over 8. Okay, so first we can work with sine theta is equal to plus root of 5 over 8. So sine inverse of that will give us the value of theta, square root of 5 over 8. So again, let's use our calculator. So before that, we have to change our calculator back to radians mode. Sorry, degrees mode. Why? Because the theta range is given in degrees. So let's do that first. So we have changed it back to degrees. So we have to do sine inverse of square root 5 over 8. And see, that comes to 52.2 degrees. So 52.2 degrees is out of this range because the maximum value that is acceptable for theta is 0 and the minimum possible value is minus 90. So this is out of range. So we cannot include this value of theta in our final answer. Now let's move on to sine theta minus square root of 5 over 8. Till now we were working with plus square root of 5 over 8. Now we'll be working with minus of that. So theta will be sine inverse of minus square root of 5 over 8. So again, let's bring out our calculator. So sine inverse of minus square root of 5 over 8, it comes to minus 52.2 degrees. So minus 52.2 degrees is well within the range given. So our final answer for theta will be minus 52.2 degrees. Okay, that's the final answer. So this was the end of part 2. Now let's move on to question B. So here we have been given these two curves. They have said that the graph of y equal to sine x and y equal to cos x, 2 cos x, is given in this diagram for this particular range of x. So the graphs intersect at point A and point B. That means at this point there is one point of intersection, and here we have the second point of intersection. So we have been asked to find out the x coordinate of A. So if we want to find out the points of intersection, so we have to equate these two equations. So it will be sine x equal to 2 cos x. So now we can take this cos and bring it to the side. So it will be sine x by cos x equals 2. So that is tan x equal to 2. So ultimately we want to find out the x value, right? So x will be equal to tan inverse of 2. So here one more thing, this is given in radians, right? Because pi. So again, when we're using our calculator, please be careful that you have to now change it again to radians mode. So next, tan inverse of 2, it gives 1.107. So in 3 significant figures, it will be 1.11. Okay, so this value, the x coordinate of A, is 1.11 radians. Okay, I hope this is clear. Now moving on to part 2. Now they have asked us to find out the y coordinate of B. Basically, we have to find out this value. Okay, so for that what we have to do is first find out the x coordinate of B. So we already have one of the x values. So let's use all sine tan cos. So this is all positive. This is sine positive. This is tan positive. And this is cos positive. So this is 0. This is minus pi by 2. This is minus pi. And this is, we only need till here. So here in the first part we have got x equals 1.11. So 1.11, it will lie in this range, right? Okay, so if 1.11 lies in this range, okay, so now we have to find out what was the other value of x. Okay, so for that, if this is 1.11, that means this is also 1.11. Okay, and if I draw another line out here, so I have, this will also be 1.11. So I want to find out what is the x coordinate of B. So the x coordinate of B is basically the angle from here all the way to here. Okay, why is that? Because here the x value should be negative, right? So for that to happen, your tan value should be negative, and tan is negative in this quadrant because here tan was positive, The previous answer for x, we had a positive value for tan, it was plus 2. So that is why I had drawn this angle in this quadrant. But here, since tan value must be negative this time because the x coordinate of B is to the left hand side in this direction where all the values of x are negative, so the value of tan should be negative. So tan is negative in this quadrant, sine quadrant, because if we look at this quadrant, the third quadrant where tan is positive, this is going beyond the range. We have till minus pi. Okay, this is the minimum possible value for x that we can have, and tan will again be negative in the cos quadrant, but again that will go beyond the range given, so we have to work with the sine quadrant. So if the total angle is minus pi and this angle is 1.11, that means this will be minus pi plus 1.11. Okay, so this will be x coordinate of B will be minus pi plus 1.11. So this should come to minus 2.03. So this is the x coordinate of B. So we have been asked to find out the y coordinate. So if we have the x value, so we can either use this equation or this equation to get the corresponding value of y, because for both the equations the y value is going to match, right, because they are intersecting at that point. So I am using this expression. You can also use this other one if you want. So yb will be equal to sine of that x coordinate. Okay, y equal to sine x. So if I want to find out the y coordinate of B, so it will be sine of the x coordinate of that point. So it will be sine of minus 2.03. So let's see how much will that come to. So sine of minus 2.03, it comes to minus 0.896. So this is your final answer. So now let's move on to the next question. That is question number 8. So here they have said the tangent to the curve with an expression of this at a point A is parallel to the line y equal to 2 minus 3x. So we have been asked to find out the equation of the tangent at A. So remember, I had written one note earlier that whenever you have two lines that are parallel to each other, that means their gradient will be equal. So here, since the tangent at A is parallel to this line, so whatever is the gradient of this line, so the tangent will have the same value of gradient. So if we use that line y equal to 2 minus 3x, so that can be arranged in this format, minus 3x plus 2. So y equal to mx plus c, where m denotes the gradient. So from here we can conclude that the gradient of the line is minus 3. So since the line is parallel to the tangent, so the tangent will also have the same gradient. Okay, so the gradient of the tangent will also be minus 3. Next, what we have to do is to find out the equation of the tangent. So tangent is again a straight line. And what is the equation to find a straight line? It is y minus y1 equals m bracket x minus x1, where we need the gradient of the line and we also need the coordinates of a point which is falling on that line. So we have already found out the gradient of the line. So next we have to find out the coordinates of a point which is falling on that tangent, and that is point A. So we have to figure out the coordinates of this point A. So for that, what we have to do is we have to differentiate the equation of the curve given. So they have said that y equal to x cube minus 9x square plus 24x minus 12. So if we differentiate this with respect to x, so it will be 3x square minus 18x plus 24. Okay, so at point A, the gradient of the tangent is minus 3. So whatever is the gradient of the tangent at that point, so for the curve, it should have the same value of gradient. That means at point A, the gradient of the tangent is equal to the gradient of the curve, and that should be equal to minus 3. Okay, so dy by dx is actually giving us the expression for the gradient of the curve. That means at point A, dy by dx should have a value of minus 3. So what we can do is now by equating this to minus 3, we should be able to get the x coordinate. So 3x square minus 18x plus 24 is equal to minus 3. So if I bring this minus 3 to the left hand side, so it will be 3x square minus 18x, 24 plus 3. So plus 27 equal to 0. So I can take 3 common. So this will be x square minus 6x plus 9 equal to 0. So this will be now equal to x square minus 6x plus 9 equal to 0. So we can now solve for x by using middle term. If you want to use the quadratic formula method, then also you can do that. You will get the same answer. But I think the middle term method is faster. So we can now do x square minus 3x plus 9 equal to 0, because minus 3x will give you minus 6x. So from this side we can take x common. So in brackets we're going to have x minus 3, and again from here we will take 3 common, so minus 3, and that will give us x minus 3 again. So see, now the two factors that we have are x minus 3 and x minus 3, that is equal to 0. So from here we can conclude that the x coordinate of A should be equal to 3. So according to the question, we have to find out the equation, right? So we also need the y coordinate of A. So to find out the y coordinate of A, we can just plug in the value of x in the equation of the curve given. So the equation of the curve was given to be this. So now just plug in the value of x in this equation. So it will be x cube, so 3 cube minus 9 into x square, so 3 square, plus 24 into 3 minus 12. So let's see how much that comes to. So 3 to the power of 3 minus 9, 3 square, plus 24 times, plus 24 times 3 minus 12, and that comes to 6. So at A, the y coordinate of that point is 6. So now we have the values of x1 and y1 as well. So here we have the value of the gradient and we have the value of x1 and y1. So now let's plug in the values. So the gradient came to minus 3. X1 was equal to how much? Let's see. 3, and y was equal to 6. Okay. So this is 3 and y1 is equal to 6. So y minus y1, so y minus 6 is equal to minus 3 bracket x minus 3. So y minus 6 is equal to minus 3x, minus 3 into minus 3 will give you plus 9. So y equal to minus 3x plus 9 plus 16. plus 9 plus 6, my bad. So your final answer will be y equal to minus 3x. 9 plus 6 is 15. So plus 15. So this is the final answer. This is the equation of the tangent at point A. And your final answer is this. Okay, so now let's move on to part 2. So this time they have given us the function f is defined by this expression for x greater than k. And k is a constant. Find the smallest value of k for f to be an increasing function. And for f to be an increasing function, f prime x must be greater than 0. Okay, so now let's find out the derivative of this. So we have f of x equals x cube minus 9x square plus 24x minus 12. So f prime x will be 3x square minus 18x plus 24. So since it's an increasing function, so f prime x is greater than 0. So we can write that 3x square minus 18x plus 24 is greater than 0. So now from here we can take 3 common. So x square minus 6x plus 8 greater than 0. So therefore x square minus 6x plus 8 is greater than 0. So next what we have to do is find out the critical values of x. So to find the critical values of x, what we have to do, we have to equate this to 0. So x square minus 6x plus 8 equal to 0. So again you can do it by quadratic formula or by middle term. I'll be doing it by middle term. So I can rewrite this as x square minus 4x minus 2x plus 8 equal to 0. So from here x will be common. So x minus 4. And from here 2 will be common. So minus 2 brackets again x minus 4. So it will be x minus 2 into x minus 4 equal to 0. So I have two values of x now. So x will be either equal to 2 and x equal to 4. So here according to the question we have to find out the smallest value of k, right? So before we do that, if I want to sketch the graph of this expression, 3x square minus 18x plus 24. So since this is a quadratic equation, so the graph should be parabola. And since the coefficient of x square is positive, okay, that means the graph should be like this. If it was negative, it would have been like this. Okay, but this case, we will be having a graph like this. So the critical values is 1 out here, which is equal to 2, and the other one out here, which is equal to 4. So ultimately it was greater than 0, right? So greater than 0 are regions out here and regions out here. So for the values of x for which we will have positive values for y, it will be in this direction, which is x less than 2, and in this direction, which is x greater than 4. So see, in this they had said that x was greater than k, and if we compare these two, that means k is going to have a value of 4. Okay, because x was greater than k and x is greater than 4, that means k has to be equal to 4. So this will be our final answer for part 2. So next let's move on to question number 10. I have skipped question number 9 because it is on vectors, and vectors is no longer included in AS Math syllabus. So now moving on to question number 10, they have said that the 1 function f is defined by fx x minus 2 whole square plus 2 for x greater than equal to c. So we have to find out the smallest possible value of c. So see over here, x can be any value greater than equal to c, right? And we have a squared term out here. So for any value of x, you will have a positive value out here. Only if the value of x is equal to 2, this squared term will be equal to 0. What I mean to say is, suppose we have f of x equals x minus 2 whole square plus 2. Suppose we had taken x is equal to 1. So if we use this value of x in this expression, it would have been 1 minus 2 whole square plus 2. So that is minus 1 whole square plus 2. 1 plus 2, that would have given us 3. If we had used some negative value, for example, minus 3, so then it would have been minus 3 minus 2 whole square plus 2 and minus 5 whole square plus 2. So 25 plus 2, which is 27. So what my point is, no matter what value of x you take, since you have a square out here, ultimately you're going to get a positive term, right? And if you add that to 2, that means you'll get some value greater than 2. But only if the square term came to 0, then you would have gotten a minimum value. So that is only possible when x is equal to 2. So when x is equal to 2, so 2 minus 2 whole square plus 2 is 0 plus 2. See, a non-positive value. Okay, so this will ultimately give you 2. You cannot have any other value which is less than 2. Because of the square term, it will always give you a positive value or some value greater than equal to 0, and when you add it with this 2, you're going to have some value greater than 2. So this is the smallest possible value of c that you can have. So your final answer will be c equal to 2. Okay, so that's the answer for part 1. Moving on to part 2. So here they have said for the following parts we have to use this value of c. Okay, so if we use this value of c, then our f of x becomes x minus 2 whole square plus 2 for x greater than equal to 4. So first we have to find out an expression for the inverse function of x. So for that what we can do is let y equal to this expression. So x minus 2 whole square plus 2, and we have to make x the subject. So for that we can take this 2 to the left hand side. So y minus 2 equals x minus 2 whole square. So since I have to take a square root now, so x minus 2 whole square is equal to y minus 2. So since I have to take a square root, please use a plus or minus sign. So this will be x minus 2 equals plus minus square root of y minus 2. So therefore x will be equal to 2 plus minus square root y minus 2. Now when you give your final answer for the inverse function, you have to decide whether it's going to be a plus out here or a minus out there. So for that what we have to use is the range of the inverse function is always equal to the domain of function f of x. So here they have said in the question that x is greater than equal to 4. So this is actually the set of input values which we call domain. So this is the domain of the function f of x. So this is going to be the range of the inverse function. So we can write that the range of the inverse function, which is f inverse of x, will be greater than equal to 4. Okay, so that is only possible if we add some more value to 2. So for our final answer for the inverse, it is going to be f inverse of x equal to 2 plus square root of x minus 2, because if it was minus here, then you're subtracting values from 2, right? So you can never have an ultimate value which is greater than equal to 4. So that was the answer for this part, finding the expression. Now we have to state the domain of the inverse. So this was the first relationship that we had used. The second relationship will be whatever is the domain of the inverse function that is equal to the range of the actual function f of x. So here whatever was the domain of the function f of x, that was equal to the range of the inverse, and here whatever is the range of the function f of x, that is going to be the domain of the inverse. So here we have to find out first the range of function f of x. So f of x was equal to x minus 2 whole square plus 2. Okay, so the minimum possible value that we can have for x from here is 4. Okay, because the values of x are starting from 4. You cannot have a value of x less than 4. So if we use that value of x in our expression, so 4 minus 2 whole square plus 2, so that is going to be 2 square plus 2, that's 4 plus 2, 6. So when you're going to increase the values of x, so suppose you have x equal to 5. So when x is equal to 5, some value greater than the minimum value, so it will be 5 minus 2 whole square plus 2. So that's 3 square 9 plus 2 11. So see, as your values of x is increasing, our values of f of x is also increasing. And when the value of x was minimum at the value of 4, we got our f of x as 6. So you cannot have any value of f of x which is less than 6. So we can write that the range for f of x will be greater than equal to 6, and whatever is the range of the function, that is equal to the domain of its inverse. So next we can write that domain of the inverse function will be equal to x, because domain is the set of input values, so set of x values, so x greater than equal to 6. So this will be our final answer for part 2. Okay, now let's move on to the next bit. So here they have said solve the equation f of x equals to 51, and we have to give our answer in this form. Okay, so f of x is basically f bracket the equation of f of x, which was x minus 2 whole square plus 2, that is equal to 51. Okay, so let's simplify this. So this will be x square minus 4x plus 4 plus 2 equals to 51. So it will be f x square. So this will be minus 4x plus 6, that is equal to 51. Okay, I hope this is clear till this point. So once we get this expression, so we have to again substitute this in place of x. So this will become x squared minus 4x plus 6 whole square. Okay, so there's a minus 2, so 6 minus 2 whole square plus 2 equals 51. So this will be x square minus 4x plus 4 whole square. So if I take this 2 to the right hand side, so 51 minus 2, that's 49. So now when I take the square root again, the plus minus sign, so x square minus 4x plus 4 is equal to plus minus square root of 49, that's plus minus 7. So This can now be written as x minus 2 whole square, right? Because if you do it by middle term, so this will be x square minus 2x minus 2x plus 4. So that is x, if you take x common, so x minus 2. And if you take 2 common out here, so again x minus 2. So now x minus 2 into x minus 2. So that is basically x minus 2 whole square. So now if I write it like this, x minus 2 whole square is equal to plus minus 7. Okay, so again when I take a square root, I cannot take square root of a negative number and get a real value. So I'm going to drop this negative sign. So I will do x minus 2 whole square equal to 7. So x minus 2 is equal to plus minus square root of 7. So x, so one answer will be x minus 2 equal to plus 7, so plus square root of 7, and x minus 2 is equal to minus square root of 7. So if I take this 2 to the other side, so x equal to 2 plus of square root of 7, and x is equal to 2 minus square root of 7. But in this we want a plus square root of b. Okay, so our final answer will be x is equal to 2 plus square root of 7, where a is equal to 2 and b is equal to 7. Okay, this is our final answer. Now let's move on to the next question, which is the last question from this paper. So they have given us a curve, part of a curve, and the line x equals 1. And they have said point A is the minimum point on the curve. And we have to show that the x coordinate of A satisfies this equation, and then we have to find out the exact value of the second derivative at point A. Okay, so let's solve it. I'm working it out on this side. So y equal to x plus 1 whole square plus x plus 1 to the power of minus 1. So if I want to find out its derivative, so this will be 2x plus 1 to the power of 2 minus 1, which is 1, minus 1 x plus 1 to the power of minus 1, which is minus 2. Now at point A, since this is a minimum point, so minimum point is a type of stationary point, right? And at stationary point, dy by dx is always equal to 0. So that is why at point A, this expression will be equal to 0. So we can write 2 bracket x plus 1 minus 1 by x plus 1 whole square is equal to 0. So this will become 2x plus 1 whole cube minus 1 equal to 0. So I can take this 1 to the right hand side. So this will become x plus 1 whole cube equals half. Okay, so we have to show that we're satisfying this equation. So we have already done that. So if I just take 1 to the other side and do not take this 2, so this will become 2x plus 1 cube equals 1. So we have shown. So next we have to find out the exact value of the second derivative. So for that, let's find out the equation of the second derivative. So second derivative is when we differentiate this dy by dx again with respect to x. So this will be 2 plus 2 bracket x plus 1 to the power of minus 3. So at point A, okay, so at point A we can write, so this is basically 2, so we can write 2 plus 2 by x plus 1 whole cube. So if we simplify this, so it will be 2 bracket x plus 1 whole cube plus 2 by x plus 1 whole cube. So we have already found out that the value of 2x plus 1 whole cube is equal to 1. Okay, so this will be equal to 1 plus 2, and x plus 1 whole cube, if you make this the subject, so that is equal to half, so we can put half out here. So that is basically 2 into 3, and that is 6. So this is our exact value of the second derivative at point A. Now let's move on to the last part of this question. So we have to show all the necessary working to find the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. So when we have to find out the volume of a shaded region about the x-axis, the formula is pi integral the x limits, so x2 and x1, y square dx. Okay, this is the formula. So this will be pi. So let's see what are our limits. So this is our x2 and this is our x1. So this will be 1, 0, y square dx. So previously they had given us that y equal to x plus 1 whole square plus 1 by x plus 1. This was the equation. So if we want to do y square, so for this you can use a plus b whole square formula. So that's a square plus 2ab plus b square. So a is this and b is this entire thing. So let's expand this now. So this will be a square, so x plus 1 whole to the power 4 plus 2ab, so 2 into x plus 1 whole square by x plus 1 plus b square, so 1 by x plus 1 whole square. So this and this gets cancelled, leaving me with this expression. So this is x plus 1 to the power 4 plus 2 bracket x plus 1 plus 1 over x plus 1 whole square, so that is equal to y square. So now let's integrate this. So if we integrate this, so let's integrate this separately. So 1, 0, x plus 1 to the power 4 plus 2 x plus 1 plus x plus 1 to the power of minus 2 dx. So this will be x plus 1 to the power of 5 by 5. So this is 1, 0 plus 2 pi, which is x plus 1 to the power of 2 by 2. Again, limits are 1 and 0 plus 2 pi. So this will be, this time it will be just pi. So plus pi. So it will be x plus 1 to the power of minus 1 by minus 1 with limits 1 and 0. So see, this 2 and this 2 can get cancelled. So the next step will be to plug in the values of the limits in place of x. So pi by 5 bracket. Now 1 plus 1, which will give us 2. So 2 to the power of 5 minus, so 0, now 0 plus 1, which is 1. So 1 to the power of 5 bracket close plus pi, again a bracket, 1 plus 1, which is 2, so 2 square minus 0 plus 1, which is 1, 1 square. So again bracket close. So pi by minus 1, so that's minus pi. So minus pi bracket, so that is going to be 1 plus 1 to the power of minus 1, which is 1 over 2. Okay, minus of 1 by 0 plus 1, so that is 1 by 1, so which is going to be 1. So now let's find out the values. So pi by 5, so this is going to be 32 minus 1 plus pi, which is going to be 4 minus 1, and minus pi, which is half, minus 1. So that is 31 by 5 pi plus 3 pi plus pi over 2. So if we find out this value, so if we take pi common and if we find out 31 over 5 plus 3 plus half, so let's see how much we get. So 31 by 5 plus 3 plus half. It comes to 97 over 10. So our final answer will be 97 over 10 pi. Okay, so that's the end of this paper. Hopefully you've understood all the working. If you've liked this video, please give me a thumbs up and subscribe to my channel and stay tuned for more such videos. Thank you. Bye bye.